Good evening, children.
Good evening.
Good evening, ma'am.
Good evening.
Good evening, ma'am.
Good evening, children. Good evening. Good evening, children.
Good evening, ma'am.
Good evening, children. Happy New Year to all of you.
Thank you, ma'am.
Thank you, ma'am.
Thank you, ma'am. Same to you, ma'am.
Thank you, children. Thank you.
Thank you, ma'am.
Thank you,
Same to
children.
you, ma'am.
Thank you. All right. So we are starting a new chapter, arithmetic progressions. So let's see the introduction to this chapter. We need to get familiar with certain terms. We'll see them one by one. The first one is sequence. What is a sequence? Some numbers arranged in a definite order according to a definite rule. So they are the keywords: definite order, definite rule. Some numbers arranged in some specific order following a definite rule, some specific rule. Okay, these numbers are said to form a sequence. Some numbers arranged in a definite order, some particular order, according to a definite rule, some particular rule. These such numbers are said to form a sequence of numbers, or a sequence of geometrical figures. The number occurring at the nth place of a sequence. The number occurring at the nth place. Nth place can be the 10th place. Nth place need not be the last place. It's not that. Nth place is maybe the 10th place or the 15th place, the 100th place, the 1000th place. The number occurring at the nth place of a sequence is called its nth term, denoted by the symbol Tn or An. Capital letter T, Tn or An. So some numbers arranged in a definite order according to a definite rule are said to form a sequence. The number occurring at the nth place need not be the last place of the sequence. And supposing the sequence has 1000 numbers, the number in the 500th position can also be called the nth place. If you don't know which position you're talking about, then we say the nth position or the nth place. The number occurring at the nth place of a sequence is called its nth term, denoted by Tn or An. Now, the definition of a sequence involves something called a definite rule, right? Now we'll see a rule. Now consider the rule An is equal to 2n plus 1. So An meaning it can be A1. You can find A1 in place of n. In place of n. So in place of n, when you give 1, 2, 3, 4 and numbers like that, you can find the number, you can find the value in the first position. See, now when n takes the value 1, n takes 1, then you will find A1. That is the first term of the sequence. When you find A2, when n is 2, here also you'll have to substitute 2 then. So when n takes the value 2, you will find the second term of the sequence. When n takes the value 3, you will find the third, the value in the third position of the sequence, and so on. So you can using this rule, you can find any the value in any position of the sequence. Here, this n and this n, they are the same. So when you find A1, so 2 into 1, 2 plus 1, 3. Plus 1, 3. So A1 is 3. Then when n takes the value 2, A2, you're finding the second term of the sequence. A2 meaning the second term of the sequence. Then here also n will be 2. So 2 into 2, 4. 4 plus 1, 5. So A2 is 5. When n takes the value 3, A3 meaning the third term of the sequence. 2 into 3, then n will be 3. So 2 into 3, 6 plus 1, 7. A3, 7. Similarly, when you substitute 4 in place of n, you can find A4, which is 9. 2 into 4, 8 plus 1, 9. Similarly, 2 into 5, 10 plus 1, 11. And so on. So this is that rule. This is that rule. 2n plus 1 is the rule. And what is the order? The order, you cannot just write 11, 9, 3. You cannot write the numbers in any random order. You cannot write, see, you have some numbers, no? 3, 5, 7, 9, 11. You cannot write them in any order. You have to write them in a definite order. What is the definite order? The first term, 3. The second term, 5. The third term, 7. The fourth term, 9. The fifth term, 11. That is what is definite order following a definite rule. The rule is 2n. In this example, the rule is 2n plus 1, and the order is 3, 5, 7, 9, 11, and so on. Thus, the numbers 3, 5, 7, 9, 11 form a sequence. In the sequence, the first term is 3, the second term is 5, the third term is 7, and so on. So a set of numbers arranged in a particular order following a particular rule is said to form a sequence. Definite order. Order is important. You cannot write the numbers in any order. Definite order, definite rule. Rule here is 2n plus 1. And the order 3, 5, 7, 9, 11, and so on. You cannot write the numbers in a different order. Then the rule will not be satisfied. Because here n is the, if you take n as 10, that means you're finding A10. That means you're finding A10. That is the value in the 10th place. The value in the 10th position of the sequence. When you substitute 10 in place of n, that means you're finding A10. You're finding A10 meaning the 10th term of the sequence. You're finding the 10th term of the sequence, which is 2 into 10, 20 plus 1, 21. So as I told you, nth place can be the first place, second place, third place, fourth place, 100th place. Now, what is an arithmetic progression? It is a sequence. What is an arithmetic progression? It's a sequence. And what is a sequence? Is what we just saw. A set of numbers arranged in a definite order following a definite rule is a sequence. So an arithmetic progression is a sequence. It's a sequence. That means in an arithmetic progression, some numbers are arranged in a specific order following a specific rule. A sequence in which, so what is the difference? Arithmetic progression is a sequence. There are different kinds of progression. We will be seeing only arithmetic progression. There are other progressions called geometric progression and harmonic progression, GP and HP. Geometric progression, harmonic progression. But we will be studying only arithmetic progression in our syllabus. A sequence in which each term differs from its preceding term by a constant is called an arithmetic progression. Am I audible and clear, children?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. All right. So a sequence in which each term differs from its preceding term by a constant is called an arithmetic progression, written as AP. This constant is called the common difference. We'll take an example. I'm just introducing the different terms in this chapter. This constant is called the common difference of the arithmetic progression. The common difference can be negative, 0, or positive. It can be negative, it can be 0, it can be positive. It can be any real value, basically. It can be any real value. An arithmetic progression with finite terms. That is, if it starts with 1 and ends with something, you know, like supposing you have 1 plus 5, say 6, 6 plus 5, 11, 11 plus 5, 7, 16, 16 plus 5, 21. And so like supposing, so you can see that we have the numbers 6, 16. So 26 will be there. 30. See, you can see, from this 6, then there is 16, then 11, 21 is there. So you know that it's going to be 26, 31. Correct? 6, 11, 16, 21. So the next number will be 26. And then it will be 31, 36, 41, 46, 51, 56, 61. So then we know that 91 will be a term of this AP. 91. Now, why is this an AP? First, why is this an AP? It's an AP because first it's a sequence. It's a sequence. You can see a set of numbers. We have to see what is the rule, we'll understand. How to find the rule, we'll understand. How to find the rule, what is the definite rule? That we'll understand how to find the rule later. Now, this is a sequence. It's a set of numbers. It's a set of numbers. It's written in a particular order. It's 1 and then 6 and then 11 and then 16. There is a rule for this. What is the rule? We'll learn how to make the rule later, I said. But you can see, why is it a sequence? Because it's a set of numbers. They are arranged in a specific order. 1 and then 6. You cannot exchange. You cannot write 1, 11 and then 6. It is 1, 6, 11, 16, 21. Okay. So this is an arithmetic progression because when you find the difference between any term and the preceding term, 6 minus 1, 5, 11 minus 6, 5. The common difference is this term minus its preceding term. Like the fourth term minus the third term, not the third term minus the fourth term. That's not the common difference. Common difference is not the 10th term minus the 11th term. It's the 11th term minus the 10th term. Common difference is the 100th term minus the 99th term. Common difference is the difference between a term and its preceding term. It's the difference between any term of the AP and its preceding term. See, we have to start with some number, and that is 1. So you cannot find 1 minus something. We are starting with 1. So it is A2 minus A1. The second term, A2 minus A1 is a common difference. Or 11 minus 6, A3 minus A2. So you can see that 6 minus 1, 5. 11 minus 6, 5. 16 minus 11, 5. 21 minus 16, 5. So each term, you can see that in the sequence, each term differs from its preceding term, previous term, by a fixed value, which is 5 in this case. So this sequence forms an arithmetic progression. Why it forms an arithmetic progression? Because every term differs from its preceding term by a fixed value, by a constant, and that constant here is 5. See, you should not do 21 minus 11. You take any term and its preceding term. So 21 minus 16, 5. 6 minus 1, 5. So a sequence in which each term differs from its preceding term by a constant, a fixed value, is called an arithmetic progression. This constant is called common difference. The common difference can be negative. It can be 0. So like 6, 6, 6, 6, 6 also forms an AP. Where the common difference is 0. The same term. First term is 6, second term is 6, third term is 6, fourth term is 6, nth term is 6. So the difference 6 minus 6, 0. So 6, 6, 6. When the sequence has the same number repeated, that sequence also forms an arithmetic progression with common difference 0. It can be negative, it can be positive. If you write the same sequence in the reverse order, if you write 21, 16, 11, if you write the same sequence in the reverse order, the common difference will become negative. You can frame, you can form some other sequence where the common difference is negative. I'm just telling you that if you write the same sequence in the reverse order, the common difference will become negative. One comma minus 4. So now when you write the numbers in the reverse order, you can see that the common difference is negative. The common difference is negative 21, 16, 11, 6, 6, okay, 6, 1, then -4, -9, and so on. So here, A2, the second term, A2. When I say A2, it's not like this, not A2 like this, A2 like this, A2 like this, A2, A10. A10 is the 10th term. A10 is the 10th term. So A2 minus A1. A2 minus A1 is the common difference, which is -5. 16 minus 21. 16 minus 21, -5. 11 minus 16, -5. 6 minus 11, -5. 1 minus 6 is -5. The common difference is negative. -4, -1, -5. -9, -4. Minus difference. -9, you should subtract. This is a term. -9 is a term. Its preceding term is -4. You must subtract them. You must find the difference. Just because -4 already has a minus sign, you cannot just ignore this minus. See here, you should write the term. A term is -9. Its preceding term is -4. A term is -9. Its preceding term is -4. You should find the difference between them. And that difference is -9 plus 5, which is, sorry, plus 4. -9 plus 4, which is -5. This is a term. This is its preceding term. Should find the difference to find the common difference. So the common difference can be negative, as in this case. As in this case, the common difference is negative. In this case, the common difference is positive. In this case, the common difference is positive. And here, the common difference is 0. Like 1 by 2, comma 1 by 2, comma 1 by 2, comma 1 by 2. Goes on like that. Common difference is 0. So finite is when you take this example, 1, 6, 11, 16, 21, so on till 91. So we know the last term of the AP. When you know the last term of the AP, it's a finite AP. Because you can count the number of terms. You know how many terms are there in the AP. See, now you cannot count. Again, you can find how many terms the AP has. We can find. We'll see all that. So when you know the last term of the AP, an AP with finite terms meaning you know the last term. You know the last, it ends with a 91. There's nothing after 91. You know the last term. You know the last term of the AP, 91. So that's a finite AP. If you didn't know this, if it's like 21 and so on like this and so on. You didn't know this 91, you know, and so on. 1, 6, 16, 1, 6, 11, 16, 21, and so on. So you don't know the last term. You don't know the last term. So the AP has infinite terms. Then it's called an infinite AP. Then it's called an infinite AP. When you know the last term of the AP, it's a finite AP. Finite AP because it has countable number of terms. You know the last term. See, there can be 1 lakh terms, but it's still finite. When you know the last term, it can have many terms. It can have, the AP can have 1 lakh terms, but it has, you know, it has 1 lakh terms. It's countable. So it's a finite AP when you know the last term. When you don't know the last term of the AP, 5, 10, 15, 20, 25, and so on. So 5, 10, 15, 20, it is an AP with common difference 5. But and so on, you don't know the last term. So it's an infinite AP. Is it fine so far, children?
Yes, ma'am.
Yes, ma'am.
Yeah, all this you can help yourself, children. Take a screenshot. Please take a screenshot. Tomorrow, most probably, I'm traveling, so I may not be able to make a class tomorrow. So take screenshots today, children. We'll not write during the session. You can complete it instead of tomorrow's class. You can complete all this and share the pictures with me later. I'll try to make the class tomorrow, but I'll just let you know by evening. Most probably, I will not be able to do.
Okay, ma'am.
Yeah. Please take a screenshot, children. Chapter Arithmetic Progression. Yeah, these examples, children, you can help yourself. It's not difficult. Please take a screenshot. This one also. So here it is -9. It's not +4. It's -4. Difference only. This is one term. -9 is one term. -4 is another term. Don't think they're adding. If they're not adding, it's -9 is one term. -4 -9 is a term. Its preceding term is -4, and you'll have to find the difference. So -9 minus -4, which is -9 plus 4.
Ma'am, can you show the previous slide?
Yeah, sure. One second.
Done, ma'am.
Yeah.
Ma'am, can you show the second slide?
Second from the beginning, is it?
Yes, ma'am.
Done, Nishita?
Yes, ma'am.
That was Nishita, right?
Yes, ma'am.
All right. I'll just wait for some time. You can just go through the slide and take a screenshot. Just go through the slide. Maybe I'll just do one of it. Look at the first one. The heading is show that each of the following progressions is an AP. Show that each of the following progressions is an AP. So first we'll have to show that the progression is an AP. Then if it is an AP, you should find the common difference and also the next term of each. First, you must show that it's an arithmetic progression. And if it is an arithmetic progression, what is the common difference and what is the next term? Okay, the first one, root 7 root 28, root 63, and so on. It's an infinite sequence. It's an infinite sequence. Now we'll have to show that it's an arithmetic progression. We'll have to show that this sequence is an arithmetic progression. So write root 28 as a mixed surd. Write root 28 as a mixed surd. Root 63 as a mixed surd. You can see here. Factorize. What are the factors of 28? 2, 14 times 2 sevens. So you can write 28 as 2 into 2 into 7. 2 into 2 into 7. Root of 2 into 2 into 7. That's what is 4 into 7. So 4 into 7. So of 2 2s, 1 2 will come out, right? So 2 root 7. 2 root 7. Or if you write this 4 into 7, square root of 4 is 2. So 2 root 7. Similarly, 9 7s are 63. 63 is 9 7s. See, if you all know it, you can just do this also. 21 times 3 7s. 7 1s. So it is root of 3 into 3 into 7. So from 3 3s, 1 3 will come out. So 3 root 7. That's what you see here also. Okay, so the thing is you'll have to express these surds as a mixed surd. This is a pure surd. Root 28 is a pure surd. Root 63 is a pure surd. It's a pure surd. You'll have to express it as a mixed surd. Mixed. We'll have to express it as a mixed surd like this. So root 28 can be written as 2 root 7. Root 63 can be written as 3 root 7. Now, how do you check if it is an arithmetic progression? 2 root 7 minus root 7. 3 root 7 minus 2 root 7. Both the difference in both the cases is root 7. See here? 2 root 7 minus root 7. What's the answer? Root 7. 3 root 7 minus 2 root 7. The answer is root 7. So 2 root 7 minus root 7 is root 7. 3 root 7 minus 2 root 7 is also root 7. So they equal. That means there is a difference which is common. The difference is common, which is called the common difference. If the difference is not common, then the sequence does not form an AP. Common difference it is. 2 root 7 minus root 7 is root 7. That is A2 minus A1 is root 7. A3 minus A2 is also root 7. So the given progression is an AP with common difference root 7. What's the next term? What is the next term? So since this is 3 root 7, the next term is 4 root 7. The next term is 4 root 7. Children, we are doing all this without using the formulae. I haven't still derived the formulae for you. We have some formulae also in this chapter for those students who have already learned this in school. So this is only the introduction. We haven't still gotten to the chapter. So there is a difference which is common, which is called the common difference, which is root 7. And based on the the arrangement here, root 7, 2 root 7, 3 root 7, going by this order, the next one should be 4 root 7. 4 root 7 meaning it is root of 16 into 7. That is 4 comes inside as 16, inside the square root as 16. So root of 112 should be the next term. Going by this pattern, the next term should be root of 112. The common difference is root 7. That is the second term minus the first term is the same as the third term minus the second term. So the progression is an arithmetic progression because you can see the common difference, which is root 7. So it is an arithmetic progression. We answered this question. What is the common difference? Root 7 is the common difference. What is the next term? After 3 root 7, the next term is 4 root 7. But since in the sequence, we had all the numbers in the sequence are mixed, pure surds. In the sequence, The numbers are pure surds. So don't leave it as 4 root 7. 4 inside the square root will be 16. 16 into root 7, which is root of 112. The next one is similar, children. Find A and B such that the numbers A, 9, B, 25 form an AP. Find A and B such that the numbers, these 4 numbers, only 4 numbers, it's not an infinite AP. A9, B25, that's all, form an AP. Okay, so we know if numbers form an AP, then the second term minus the first term is the same as the third term minus the second. That is A2 minus A1 is equal to A3 minus A2 is equal to A4 minus A3. This is A1, A1, A2, A3, A4. So you can see here, see 9 minus A will be the same as is equal to B minus 9 is equal to 25 minus B is equal to 25 minus B. Now equate this one first to find the value of B. B minus 9 is equal to 25 minus B. Equate this. You cannot do all the 3 at the same time. B minus 9 is equal to 25 minus B. B minus 9 is equal to 25 minus B. So on solving, you'll get 2B is equal to 34 or B is equal to 17. Now you found B is 17. Now equate these two. Now you got B is 17. Equate these two. 9 minus A is equal to B minus 9. But B is 17. So 17 minus 9. On solving, you find A is equal to 1. So the value of A is 1 and B, this is 1 and this is 17. So see, 9 minus 1, 8. 17 minus 9 is 8. 25 minus 17 is 8. Screenshot, children. Okay, this exercise is for you. We'll just do randomly. Tell me if the 14th one forms an AP, children. No, not the 14, the 16th one. 16.
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
16, yes. Okay. Should you think again, children, all of you? What is A square minus A, children?
No, ma'am. A into A minus 1, ma'am.
Yeah. Then what is A cube minus A square? Very good answer, Priyadarshini. Come tell me, tell again, let the class listen to that. Priyadarshini, what is A square minus A?
Ma'am, A of A minus 1, ma'am.
Very good, Priyadarshini. What is A cube minus A square?
A square of A minus 1, ma'am.
Is the difference the same?
No, ma'am.
No. A into A minus 1, then A square into A minus 1, then you'll get A cubed into A minus 1. But there is you can find the difference, but there is no common difference. The difference is different. The second term minus the first term is not the same as the third term minus the second term. Is not the same as the fourth term minus the third term. The difference is not the same everywhere. So A square, A cubed, A to the power 4 does not form an arithmetic progression. In fact, it's a geometric progression. In geometric progression, the ratio must be the same. That is A square by A should be equal to a cubed by a square, should be equal to a to the power 4 by a cubed. What is a square divided by a? What is second term divided by? Arithmetic progression is difference between the second and the first term. Geometric progression is the ratio between the terms. What is the ratio of the second term to the first term? A square by a. A. What is a cubed divided by a square?
A, ma'am.
Yeah. What is a to the power 4 divided by a cubed?
A, ma'am.
Yeah. So a square by a is equal to a cubed by a square. The ratio of any term to its preceding term is a constant, not the difference. The ratio in a sequence, if the ratio of any term to its preceding term is a constant, then that sequence, that's called a common ratio. Like we say common difference, it's a common ratio. So when in the existence of a common ratio, the sequence is set to form a geometric progression. Anyways, we are not going to learn that in our syllabus. I'm just telling you. A sequence in which the ratio between any term and its preceding term, the ratio between any term and its preceding term is a constant. Such a sequence is said to be geometric progression. Common ratio. The ratio is called the common ratio. A square by a is a. A cubed by a square. A to the power 4. How do we, when bases are same and its division, we need to subtract the powers. So 2 minus 1, 1. I hope we are doing that. A cubed divided by a square. So 3 minus 2, 1. A to the power 3 minus 2. A to the power 3 minus 2. So a to the power 1. Which is a. Similarly, a to the power 4 divided by is a cubed. So that is a to the power 4 minus 3, a to the power 1. The ratio is the same everywhere. So a square, a cubed, a to the power 4 forms a geometric progression. Right. What about the 15th one, children? Okay, now 16th one. Does the sequence form an arithmetic progression? 16th one?
No, ma'am.
No.
No, ma'am.
Yeah, because as Priyadarshini said, what is the difference between a square and a? A square minus a. You can only take a common and write a minus 1. And if you find a cubed minus a square, a cubed minus a square, you can take out a square common and write it as a minus 1. So you can see that the difference is not the same. A into a minus 1, then it is a square into a minus 1. The difference is not the same. So in the 16th one, the sequence does not form an arithmetic progression. Instead, it forms a geometric progression because of the presence of a common ratio, not a common difference. We can see a common ratio there. All right. What about the 17th one?
Ma'am, it is AP, ma'am.
17th one forms an AP?
2 root 2. Root 2 is
2 root 2, ma'am.
Yeah, root 8 is 2 root 2. What about 18? Root 18?
3 root 2, ma'am.
3
Root
root 2.
30?
4 root 2, ma'am.
4 root 2. So yes. So in the sequence we have root 2, comma 2 root 2, comma 3 root 2, comma 4 root 2, and so on. Okay. So say, what is the common difference?
The root 2, ma'am.
Root 2 is a common difference. All right. Why is the class quiet today? Root 2 is a common difference. Only 1 or 2 of us are participating. So root 2 is a common difference. And hence a sequence forms an AP. Okay. That's all. It's a very simple concept, children. That's it. If the difference between any term and its preceding term is a constant, then that sequence forms an arithmetic progression. That's all. What about the 10th one? Please work the 10th one and tell me.
Ma'am,
Yes.
it is an AP, ma'am.
It's an AP.
It is an AP, ma'am.
What is the common difference?
Root 2, ma'am.
Root 2 is a common difference. Correct. Root 2 is a common difference. Okay. So because it is 3 plus root 2 minus 3, the preceding term. So 3 and minus 3 will get cancelled and it's root 2. The difference is root 2. You should not say common difference. The difference is root 2. Next, 3 plus 2 root 2 minus 3 plus root 2. So that is 3 plus 2 root 2 minus 3 minus root 2. You must write the two terms and put a minus sign in the middle. Write a term and its preceding term and put a minus sign in the middle. You are subtracting them. So 3 minus 3 will get cancelled. 2 root 2 minus root 2 is root 2. Is root 2. So similarly, you can work this also. You'll get the same thing, root 2. So the difference is root 2 everywhere. So the common difference is root 2. The difference is root 2 everywhere. So the common difference is root 2. So the terms form an arithmetic progression. Children, is 5 square minus 1 square 4 square?
No, ma'am.
No,
No, ma'am.
not like that.
No,
Yeah,
ma'am.
what is 5 square? 25. What is 1 square? 1. So you should rewrite the terms. You should write it as 1, 25, 49, and then check the common difference. 73 and so on. So 25 minus 1 is 24. 49 minus 25 is 24. 73 minus 49. 24, yeah, looks like 24. Yes. So the last one, the 20th one, forms an arithmetic progression. So we shouldn't be like, oh, 1 square, 5 square, 7 square, and 73. 73 looks like an odd one out there. So it doesn't form an AP. It's not like that. Please check. Don't judge by just looking at the numbers. Because 1 square, 5 square, 7 square, all squares, but 73 is not expressed as a square number. So it cannot be an arithmetic progression. No, we are not going to judge like that. Please work the value of 1 square, 1, 5 square, 25, 7 square, 49. So the numbers are 1, 25, 49, 73. Please find the difference. 25 minus 1, 49 minus 25, 73 minus 49. Find the difference. If it's the same, that means the difference is common, which is a common difference. And so the sequence forms an arithmetic progression. So in that sense, it's very simple, children. These are the examples you can try. Just do all this orally. Don't spend a lot of time working this because we have other, important things also to do. So don't spend 2 hours to work this. You can just pick some, sequences in random and check. If you have understood well, that's it. Yeah, this one also. Take a screenshot. Go through this also. For this, I don't have the answers, children. I thought it's simple for you. I don't have the answers. I didn't make the answers for these. Yeah, for these, I've prepared the answers. Take a screenshot. Here are the answers. Here are the answers for the third and the fourth one. So let me do the fourth one for you. The amount of money, what is the heading? In which of the following situations does the list of numbers involved make an arithmetic progression and why? In which of the following situations, there are 4 situations given to us, does the list of numbers involved make an arithmetic progression and why? I think we'll do the second and the fourth one. Let me do the fourth one first. The amount of money in the account every year when rupees 10,000 is deposited at compound interest at 8% per annum. So what numbers form the, that is, what are the numbers in the sequence? The amount of money in the account every year, those numbers, the money in my account this year, at the beginning of this year, that will be the first term. The amount of money in my account at the beginning of the next year, 2023, will be the second term. At the money in my account at the beginning of 2024 will be the third term. 2025 is the fourth term, and so on. Yeah, so the amount of money in a person's account every year, those values form the terms of the sequence, form the different terms of the sequence. So when rupees 10,000 is deposited at compound interest at 8% per annum, all right. So that means, see, when you deposit, you have 10,000 in your account. At the beginning of the first year, you have 10,000. You have deposited because the bank will not give you interest as soon as you give money to the bank. At the completion of a specific term, the interest is credited to your account. When you deposit 10,000, the bank does not immediately give you interest. Interest for what period? Today you give them. Today you open an account. Today itself, how will the bank give you interest? Only after the completion of a specific period, you will be paid interest for the amount you have deposited. So 10,000 is the money at the beginning of the first year. So 10,000 will be 10,000. Don't calculate 8% for this. Today only I put this money in the bank. So this is the first term of the sequence. So the first term of the sequence is 10,000. Now after 1 year, it's given to us that the bank is going to pay us 8% interest. So 10,000 is my money. I'm going to receive 8% of 10,000. This is the interest. This is the interest. 8% means 8 by 100 of 10,000. This is my money. This money is there. On my money, 8% I'm getting interest. So this is the interest portion. This is the interest portion. When you work that, it is 10,000 plus 800. 8% of 10,000 is 800. So that means at the beginning of the next year, in my account, I'll find 10,800. I'm happy. This year, 10,000. Next year, when I check my balance, next year, same time when I check my balance, it's 10,800. The bank has given me 800 rupees as interest for holding 10,000 in that bank for 1 year. So this will be the second term in the list. This will be the second term in the sequence. Then at the beginning of the third year, this is the money at the beginning of the first year, second year, third year. Third year, I'll get interest for this. See, now 10th, I did not take home the interest portion. Interest is in the bank. I did not take it. It's lying in the bank. So now at the beginning of the second year, the value of the money is 10,800. So at the beginning of the third year, the interest will be given on 10,800 because it's compound interest. If it is simple interest, it will be on 10,000 always. It's compound interest. So the interest will be given on the recent or the latest money lying in the bank. So on 10,800 it will be. Simple interest will be on the principal value of 10,000. Compound interest will be on the previous balance. So now in the bank I have 10,800 rupees. I'm going to get an interest of 8% on 10,800. Interest is 864. So 10,800 plus 864, 11,664. This is the money in the bank at the beginning of the third year. So that will be the third term of the sequence. Fourth year on 11,664, on this money I'll get, because I've left this money in the bank. The banker is using my money, and it's in the bank. The banker is using my money. He would have let this out as a loan to some person, and he's going to get higher rate of interest from that person. That is why the bank pays you interest, because it's using your money. So this is your money in the bank, and on this you will get 8% interest. This is the interest calculation. 8% of 11,664. This is the interest portion, like this. So we have generated the first, second, third, and the fourth terms of the sequence. And when you find A2 minus A1 and A3 minus A2, you will see that the difference is not the same. So this sequence does not form an AP. This list of numbers does not form an AP. Interest. Any doubt, children?
Ma'am, is it compound interest formula that A2 is equal to 10,000 plus 10,000 into 8 by 100?
So compound interest formula is different. You can also do it like this. Amount is equal to P into 1 plus R by 100 to the power N. So you can use this formula also to get these values, to get 10,800, this one and this one. So all that you have to do is in place of principal, you should take 10,000 because the principal is 10,000. The rate is 8%. When you put 2 here, when n is 2, you will get this 10,800. When you take n as 3, you will get 11,000. You will get A3. See, if you're using this formula, you should not change P and R. If you're using this formula, you should not change P and R. P is 10,000. R is 8. You should change the value of N. You should change the value of N. N1, N2, N3, N4, and so on. And when you find n, when you take n as 1, you will get the second value. You will get this one because you're finding the amount. Amount meaning principal plus interest you're getting. So when you take n as 1, you will get the second value 10,800. That's why I worked it like this.
Okay, ma'am.
If you take n as 2, you will get the amount at the end of 2 years. That is at the beginning of the third year. I'll let you know. So when you generate the different values, that is the money lying in the account at the beginning of every year. So this is the list. We've got 4 numbers. When you find the difference between these two and the difference between these two, you see that the difference is not the same. So the numbers do not form an AP. The list of numbers do not form an AP. I want you to go through this and let's discuss this in the next class. Okay, let me do it now. I might forget. So the amount of air present in a cylinder when a vacuum pump removes 1/4 of the air remaining in the cylinder at a time. So now, supposing there are X units of air in the cylinder, okay, the first term will be X because now the cylinder is say full. I don't know if it is full because if nothing is given, the amount of air present in the cylinder. Okay, so the air fully in the cylinder. So this is the air. We'll say that there are X units of air in the cylinder at the beginning. Now the second term will be the vacuum pump removes 1/4 of the air. How much of air is there? X units. And the vacuum pump removes 1/4 of X. 1/4 of whatever air is in it. 1/4 of the air remaining in the cylinder. So 1/4 of what is the air remaining in the cylinder? X is there in the cylinder. So 1/4 of X. When you subtract, you'll get 3/4X. So 3/4X is the volume of the air that remains in the cylinder. Originally X. 1/4 of X is removed. So now what remains in the cylinder is 3/4X. Now 3/4X minus 1/4 of whatever is remaining. See, remaining is this. See, we start with X. We start with X. See here, it's given. We are not doing anything by meaning according to our wish. 1/4 of the air remaining in the cylinder. 1/4 means 1/4. Off means into. Air remaining. Whatever is the air remaining, you should substitute. So originally X. So the first term is X. Then X minus 1/4 of X because X is remaining, right? X is there in the tank or the cylinder. So X minus it removes. So you'll have to subtract. It's a vacuum pump which and you're evacuating. You're removing the air from the cylinder. So you should subtract, not add. Minus 1/4 of X. So when you subtract, you get 3/4X. That is the second term. Now, what air will remain again when 1/4 is removed? How much is there? 3/4X is there. And from this, how much is removed? How much is removed means 1/4 of whatever is remaining. What is remaining? This one only is remaining. So when you work this, you get 9/16X. Now from 9/16X is remaining in the cylinder. This is remaining in the cylinder. Now again 1/4 of what is remaining is removed. 1/4 of what is remaining is removed. So 1/4 of 9/16X is removed. This is removed. So this is again the remaining value. It goes on like that. It goes on like that, and when you find the difference, When you subtract these two and when you subtract these two, you see that you get different values. A2 minus A1 is not the same. You have to work and see that. You work and see 3 by 4x minus x and 9 by 16x minus 3 by 4x. When you work, you will not get the same value. So this list of numbers do not form an arithmetic progression. Have you all taken the screenshots, children? No confusion, right?
No, ma'am.
All right. Now we'll derive the expression to find the general term of an AP. Now what is general term of an AP? The nth term of an AP is called its general term. The nth term of an AP is called its general term. Now let's derive the expression to find the general term or the nth term of an AP. We'll derive the expression to find the general term, or which is also called the nth term, which is also called the general term of an AP. Okay. So let's now one thing I have to tell you is now let's generate an AP. Say like 2 plus 3 5, 5 plus 3 8, 8 plus see you can also generate the AP like this, like the way I'm doing now. I just start with some number 2 plus 5 8. Oh sorry, 2 plus 3 5, 5 plus 3 8, 8 plus 3 11, 11 plus 3 14. 14 plus 3, 17 and so on. So you will see the common difference will be 3. 5 minus 2, 3. 8 minus 5, 3. 11 minus 8, 3. 14 minus 11, 3. So the sequence forms an arithmetic progression. How do you find the common difference? Second term minus first term. Third term minus second term. And if you know the first term and the common difference, how do you generate the AP? You can just have to write the first term, like supposing 3. Supposing the first term is 3. And supposing the common difference is 7. 3. 3 plus 7, 10. 10 plus, supposing the common difference is 7. Supposing the common difference is 7. The first term is 3. 3. 3 plus 7, 10. 10 plus 7, 17. 17 plus 7, 24. 24 plus 7, 31 and so on. Okay, and you can see the common difference. See, what is, we said the common difference is 7. See here, 10 minus 3, 7. 17 minus 10, 7. 24 minus 17, 7. 30, this one minus this one, 7. See, though we are adding, you can see, when you check, you can see the common difference is 7. It's not minus 7, it's 7. So when you know the first term and the common difference, keep adding the common difference to the previous term to generate the terms of the AP. Now, this numerical example should help you. Supposing the common difference is, supposing A is 7, and supposing the common difference is, okay, just say 11. So the first term is 7. The common difference is 11. So 7. 7 plus 11, 18. 18 plus 11. Write the first term A plus the common difference. 7 plus 11, 18. 18 plus 11. Keep adding the common difference. 18 plus 11, 29. 29 plus 11, 40. 40 plus 11, 51. And so on. So now see if you're getting the common difference. 51 minus 40, 11. 40 minus 29, 11. 29 minus 18 is 11. 18 minus 7 is 11. Okay, so let A be the first term. So like to generate the arithmetic progression, what we do is we need the first term and the common difference. To generate the arithmetic progression, to generate the terms of the arithmetic progression, we need the first term and the common difference. Only then you can generate. Supposing you know the first term, you don't know the common difference, then you cannot find out the terms of the AP. Or supposing you know the common difference, but you don't know the first term, you cannot generate the AP. So to generate the AP, you need two things. You definitely need two things: the common difference and the first term. The first term and the common difference, both of them should be available. Only then you can find out the terms of the AP. So that's why we say let the first term be A. Let A be the first term of the AP and let the common difference be D. Then the terms of the AP are we ready, children? Are we all following me?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. So I was trying to tell you why suddenly I'm saying let the first term be A, let the common difference be D. Because to generate the terms of the AP, you need the first term and the common difference. So let A be the first term. See, when you say let A be the first term and D be the common difference, you will be deriving that expression in terms of A and D. See, you can say let X be the first term and Y be the common difference. Okay, nothing wrong. You will be deriving the general term in terms of X and Y, that's all. If you say let the first term be X and the common difference be Y, then you will be deriving the general term of the AP in terms of X and Y, that's all. So we are saying let the first term be A, let the common difference be D. Then the terms of the AP are, you can see here. So what's the first term? A1. What's the second term? A2. Third term? A3. Fourth term? A4. That nth term is what we're trying to find. What is that expression for the nth term? We're trying to derive this. How is it A plus n minus 1 into D? We're going to understand that. So what's the first term? The first term is A itself, because let A be the first term. So the first term is A itself. And how can you express A? How can you see now? You want in the expression, you want the common difference also. So A means A plus 0D. Is this correct, children? A means A plus 0D. Yes or no, children? What is 0D? 0. So A plus 0 is A only. 0D means 0 into D. 0. And that coefficient 0 can be expressed as, you should write as something minus 1. You must write it. See, the coefficient of D is 0. You must write that as something minus 1. What minus 1 is 0? 1 minus 1 only is 0. So it's 1 minus 1. So you get the first term is nothing but A plus 1 minus 1 into D. Let me repeat that. Write the first term A1. That's nothing but A. I want to write it using D. So, but there is no D, no. A is, the first term is only A. There is no D in it. Okay, so let's write as A plus 0D. Now, I want to write the coefficient 0. That is the coefficient of D, which is 0, as something minus 1. So, A plus, what minus 1? 1 minus 1 only is 0. So, you can write A as A plus 1 minus 1 into D. So the first term is A plus 1 minus, all are the same. Everything is A. Everything amounts to A only. A is A plus 0D is A plus 1 minus 1 into D is also A. 1 minus 1 is 0, 0D is 0, A plus 0 is A. Everything is A only there. We're just writing that A in different ways. A1 we know is A. The first, when we write A1, that is, it's a first term. A1 is the first term. The first term is A. You can write it as A plus 0D, and you can further write it as A plus 1 minus 1 into D. So if it's the first term, it is A plus 1 minus 1 into D. Now let's see the second term. What is the second term? The first term plus the common difference. I just told you now. When you know the first term is 3 and the common difference is 5, 3 plus 5. 8. 8 plus, that is whatever is the first term plus the common difference will give you the second term. We just did that. We just did that. Supposing A is 3 and the common difference is 5. Then the terms will be, the first term is 3. The first term is 3. The second term will be 3 plus 5, 8. 8 plus 5, 13. 13 plus 5, 18, and so on. So the second term will be whatever is the first term, A1 plus the common difference. But the first term A1 is A. So it is A plus D. Now you want to write the coefficient of D, which is 1, as something minus 1 only you want to write. Something minus 1. What minus 1 is 1D. So you can write that 1D as 2 minus 1 into D. See, you want to write 2 minus 1 only. What minus 1? 2 minus 1. Why 2 minus 1? Because 2 minus 1 is 1. So the second term is the first term plus a common difference. The first term is A plus D. And D means 1D. 1D can be written as something minus 1. 2 minus 1. 2 minus 1 is 1. 1D. So this is also A plus 1D. So the second term is A. If with the first term, 1 minus 1 into D. If with the second term, 2 minus 1 into D. So the third term will be 3 minus 1 into D. Going by that rhythm. Okay, let's do the third one. A3 is a second term plus a common difference, like we did 3. 3 plus 5, 8. The second term, 8 plus 5, 13. The third term, 13 plus 5, 18. Like that. We use the previous term to get the next term. So now A3 will be the second term plus a common difference. A3, the third term will be the second term plus a common difference. What is the second term? The second term is A plus D. See here we have A plus D. A is the first term, A plus D is the second term. A plus D is the second term. So the second term is A plus D. Then this plus D. So it's A plus 2D. A plus 2D is the second term, the third term. The third term is A plus 2D. And how do you write 2? You can write 2 as 3 minus 1. You can write 2 as something minus 1, 3 minus 1. So A plus 2D is nothing but A plus 2 can be written as 3 minus 1 into D. So what's the third term? A plus 3 minus 1 into D. The fourth term, 4 minus 1 into D. So the nth term will be A plus n minus 1 into D. So if you want to find any particular term of the AP, simply use A plus n minus 1 into D. So this expression A plus n minus 1 into D is the expression which is used to find the nth term or the general term of the AP. Simply writing the coefficient of D as something minus 1. 1 minus 1, 2 minus 1, 3 minus 1, 4 minus 1, 5 minus 1. So fourth term means 4 minus 1. Third term is 3 minus 1. Second term is 2 minus 1. So the nth term will be A plus n minus 1 into D. So going by, after understanding the pattern in A2, A3 and A4, after observing the pattern in A2, A3 and A4, we conclude that AN should be given by A plus n minus 1 into D. So the nth term of the AP, so see this is the conclusion. The nth term of an AP whose first term is A and common difference is D is given by AN is equal to A plus n minus 1 into D. The nth term is also called the general term of the AP. Is it clear, children?
Yes,
Yes,
ma'am.
ma'am.
All right. Take a screenshot. Please write all this in your notebook. Take a screenshot, children. Yeah, take a screenshot of these also. This is the next one. After the derivation, this is the next one. Is it over?
Yes, ma'am.
Done?
Yes, ma'am. Yes, ma'am.
This one, we'll see this in the next class, but just finish writing this. How to find the sum to n terms. Sum to n terms. What we just understood is the expression to find a particular term of the AP. You want to find the 10th term, you want to find the 20th term. So if you want to find a general term of the AP, we derive that expression now, a plus n minus 1 into d. So a plus n minus 1 into d is the expression which is used to find any particular term of the AP, general term of the AP. Now this is the derivation to find the sum to n terms. You want to find the sum to the first 10 terms. You want to find the sum to the first 20 terms. Sum to n terms meaning the first 10 terms, first 10 terms, first 20 terms. Sum to first n terms. Sum to the first 10 terms of the AP. Take a screenshot, children. Yeah. This is an alternate derivation. That's all. It's another way of deriving. Some small changes. That's it. In fact, one small change. These are the two different ways you can present the derivation to find the expression, to find the sum to first n terms of the AP. What are children? This and this? Is it over?
Yes, ma'am.
All right, children. So we have not still discussed this in the class. The derivation to find the sum to first 10 terms of the AP, we haven't discussed. We'll do this in the next class, but I want you to write out the contents of all the screenshots you have taken today. Please complete all this in your classwork. We'll discuss this in the next class. Class, use the emoji, raise your hand. Oh my God, 1 second. Arnav, Tirunesh, Priyadarshini, Parkavi, Shriya, Manasa, Shivani, Nivedita, Lakshita, Balaharish, Nishita, Shruti, Subiksha, Nafi, Srinivasan, Priya, Sudarshan, Muttuvel, Akshayram, Anish, Rakshan and Harshita. Very good. All right, children, as I had texted you on WhatsApp, we'll wind up the session. I said I can do only till 8 o'clock today. I think it's 15 minutes past 8. All right, children. So that's it for today's session. Thank you so much. You may leave the meeting. Thank you, children.
Thank you, ma'am.
Thank you, children.
Thank you.
Thank you. Just a second.